Hi everyone, I'm Rajkamalai and welcome back to the brand new series of AI product engineering. And in continuation to the system design playlist, today I'm going to talk about capacity planning for designing a WhatsApp for 100 million users. So I'm going to create a capacity planning sheet so that I can design a WhatsApp kind of platform, or I would say mini WhatsApp kind of platform which can serve 100 million users. Okay, so in today's agenda, if we'll talk about, I'm going to talk about the assumptions in terms of the whatever the market research I have done as a part of building this mini WhatsApp kind of platform which can serve 100 million users. So there, as a part of market research, I have taken some of the assumptions which is in line with the real-time WhatsApp app. So what all daily active user estimation I have taken, I will let you know. What are the messages per day we are taking as a assumption for this estimation, that also I'm going to discuss with you. Then read request per second, then write request per second, then peak request per second. Similarly, there are other matrices like storage estimation, bandwidth estimation, and then database estimation, CDN requirement, backup estimation, then future growth, like 1 year plan, 5 year plan, and 10 year plan. So these all things I have planned for this today's session as a part of capacity planning. Then followed by that, I will be going and discussing about what all assumption I have taken, the calculation I will show you live for WhatsApp capacity planning. And then I will also show you how the final architecture of mini WhatsApp kind of platform looks like, and what all scaling strategies we can take into the consideration. Okay, so without further delay, let's get started. Okay, all right, guys. Let me open this capacity planning sheet. So we'll go through one by one so that it will be easier for you to understand. So guys, I have created this spreadsheet. If you look into that sheet, so this capacity planning that we are doing here, it is for the 100 million user, right? So that's what I have mentioned as a monthly active user, as a 100 million user. However, as per the market research, the current monthly active user for the WhatsApp is of order of 3 billion to 3.3 billion, and this is as per year 2026 report. Okay, and the daily active user will be in general 83% of monthly active users. So that's what as assumption I have taken here. Then next, message sent per user per day. So here the assumption we have taken 65. This is also coming from the all the marketing research and the analysis that I have done. And talking about the media message fraction, so I would say out of 100 messages, 30 messages would be related to the media. That's how you can understand, right? Or in general, a person when is communicating to their peer, their friend, so out of 100 messages, 30 messages they are going to communicate in terms of the media, sending images, sending videos, audios, voice notes, all those things. So there's so that assumption we are taking here. Apart from that, peak to average traffic factor. So in terms of the scaling, in general we will be taking 3 times, right? Whenever we are generally going to talk about scaling something, be it database scaling, or I would say network bandwidth, CDN bandwidth scaling. So the scaling factor or application factor that we are going to consider, it is a 3, or in general 3, between 3 to 5 we can take. I mean, in some of the system design, people also consider 5 as a scaling factor or peak factor. Then other assumption is read to write ratio. So if you talk about read to write ratio, so it says 4. I mean, out of generally what it says, each messages write generate 4 reads. So if I'll send one message, so generally four people will be reading that message. So that's how the average trends follow across the globe for WhatsApp application. So the ratio, read to write ratio, is 4 is to 1. For one write, 4 reads in general. Then seconds in a day, that is a hard coded. I mean, if you just calculate it, so 24 hours into 60 into 60, right? 24 hours into 60 into 60, yeah, that's how it is, that will be going to constant. So these are the assumption that we are taking. Then at message and media size assumption, what assumption we are taking, let's go through it. So average text message size would be 1000 bytes. So this is what the I mean my research says, the text payload plus metadata plus encryption overload is approximately 1 KB, which is industry standard WhatsApp SDI benchmark also, as per the Byte Go, GFG, and Educative. And these are the resources, I mean, we are referring for coming to this assumption for average text message size. I hope you guys are able to understand that. Then average media payload size, the size, I mean the payload which is delivered, right? The average media payload size, that is we are considering 1,50,000 bytes. So WhatsApp compression images less than 100 KB, or voice note and voice notes between this 30 to 80 KB, videos previewed, blended average one. So blended average that it's considering for all the kind of media consideration is around 150 KB. That's what it is mentioned here. Okay. Then next as I mentioned, server side message retention. So in general 30 days is the retention. So server stores message only until delivered. So suppose you are not connected to your WhatsApp server through the internet for more than 30 days, and somebody sends something to you, might be after 30 days you might not receive the message that your friend would have sent to you. So in general, uh, whatsapp's it will be stored on WhatsApp server till next 30 days until it got delivered. If it is more I mean if it got delayed more than 30 days, then there is a high chance that that message got lost. Then there is a next assumption with respect to the media storage retention period, that is 90 days. Okay, so for message it is 30 days, and for the media storage retention, which I mean combines your audio, video, images, all those stuffs. Then replication factor we are taking 3, right? For the high availability, for the fault tolerance purpose, this triple replication across availability zones for the 99%, 99.99% durability. So this is something, the availability I mean availability we are considering while creating this mini WhatsApp kind of platform. So considering 99.99% availability with 3 replication factor, we can achieve this much availability. Then a backup size multiplier. So yeah, so for the backup size generally 1.5 with the actual storage in terms of the backup size multiplier, if you are considering, so it will be 1.5 times to the actual storage. So the primary size of for the daily increment plus weekly snapshot will this suppose this considering this as a raw or actual storage. And then if we are going to calculate the backup size multiplier, then we are going to multiply it by 1.5. Then database overhead. So in general, apart from the storage, there are, because at DB side there are many activities that runs underneath indexing, right? For every read and write, DB underneath create the index for the to optimize search. Inside that, I mean underneath, it maintains the B plus tree to store those information and faster retrieval. Similarly, there is a write ahead log, right? So it ensure that and these are the, I mean, advanced, these are the pre-activities before reading and writing any records to the database. So uh, it can avoid any runtime failure, okay, at the database level. So for those kind of activities or metadata indexes and the write ahead log, 30% overhead we are considering, okay, on top of the raw data size. Then CDN cache hit rate for the media, we are considering 75%. So guys, for WhatsApp it's 75% as per the market research, what I found. But it again varies platform to platform. As per my market research, when I was doing the capacity planning for YouTube, there I find it was 98.5% to 99% hit rate, right, for the CDN cache. So whatever the data we generally request on the YouTube server, generally for 98.5% of the time or 99% of the time it comes from the CDN edge servers only. But here the situation is different. So as whatever the data I got from the market research, those assumption I'm taking into the consideration. Then there is an annual user growth rate. We are considering 8% as per the, this is compound annual growth rate, 8.9%. Okay, so here for the safer side, we are considering 8% for our this mini WhatsApp kind of platform capacity planning. Then daily active user estimation. This is one of the deliverables that we are trying to estimate as a part of WhatsApp capacity planning. Okay, so daily active user. So in order to calculate that, what we will be doing. So this is nothing but monthly active user. We have considered 100 million user, and now will be the 83%, I believe, 83%. Yeah, 83% of the monthly active user. So so it will be coming as a uh, 83 million. Yeah, 83 million. Yeah. Then a daily app opens total. So generally, in general, it DAO shows the number of users, right? Daily active user. Then uh, research says 23 times, right? User per day opens WhatsApp. So on that matrix, on that uh, research data, I'm just estimating daily app opens metric as well, right? So this is what it is for the considering the 100 million user base. Then masses per day, if I'm going to calculate, so total masses per day, right? So it is saying the daily active user multiplied with masses per user per day. So this is nothing but, see, daily active user 27, daily active user multiplied by c7 what it tells, message sent per user per day, right? This is the assumption we have taken into consideration as per the market research data. So 65, we are just multiplying it with the DAO, and we're getting that data. Similarly, text message. So out of this total message per day, what is the text message, right, per day? So generally, I mean, we are considering 70% of the data, right, is the text message, and 30% is the media data, right? On the basis of this calculation, RDNC, this is the formula logic. Then voice notes per day. So even in the WhatsApp, you might have seen there is a feature of voice note sending as well, right? Attaching the voice note. So as per the research, I mean market research, it is coming as a 4.7% voice notes. Okay, it coming from the directly official WhatsApp data. So for that, what I'm doing, see, C32, which says total message. So out, so for this total message per day, what proportion voice notes we are sending, right, per day? So that is the 4.7%. So that's how it got calculated. Then we are as a part of next deliverable, we are going to calculate read, write, and peak request per second. So average, if we're going to calculate average write requests per second, right? So this is the total message per day. So total message, this is coming from here, line number 32, this data divided by uh, per day. This is the per day, right? Now we have to calculate per second. That's what RPS mean, request per second, right? So we are just that data with 86,400. Then for the read, basically, so a read is coming from this, yeah, average read RPS. So average write into read. So read write ratio. So read write ratio was the 4:1, right? So this will be the 4 times of this write. So that's what we have done. Then total average RPS, nothing but this is the addition of this one only. Okay. See, 32 312 210, right? That's what it's coming. Then in terms of the peak writes, uh, just multiply this value by 3. Okay, peak read, multiply this value by 3, then total peak, it's just addition of this value. Then just coming to the storage estimation for daily text storage, daily text storage raw. In order to calculate that, what is saying, text message per day. Okay, so text message per day, if you're going to see, so this is the text message per day, this much, right? And this is the message per day, and in general the size will be uh, for the text message 1 KB, right? 1 KB, that's what we have presumed average text message size, so multiplied by 1000 bytes. So that's what uh, value we are getting as a part of those computation. Then daily media, for media it will be, for every media size it is of 150 KB of order. So we are just multiplying media message per day by 150 KB. So that's how it is getting calculated. So in order to calculate that, you have to go line number 34. Here message, media message per day, right? This is what it is, then multiplied by 150 KB. Then total storage, I believe this is the sum of this only. Okay, yeah, this is the sum of, see, 24, 65, 51. This is what it's coming. Then we are just converting into the terabyte, because this is the uh, bytes per day, and now we are just converting into the terabyte, TB. Okay, just dividing by 10 to power of 12. Then there is a text message queue for the 30 days. For that calculation, we need to have this text byte per day multiplied by 30. So text byte. Okay. So this daily text storage, which is nothing but text message per day, right? So this I'm multiplying by 30, then dividing by 10 to the power 9. So it will give this text message queue. And here I'm multiplying C17 as well, because for there is some assumption for text message queue. Yeah, 30 days, right? So that's what I'm just multiplying it. Then media blob storage, the default storage is third for media related data, right? Be it text, audio, video, or any, yeah, and this kind of data we are storing for, I mean, WhatsApp generally store it for the 90 days. So media bytes per day multiplied by 90, that's how easy the calculation is. So C50, this is the media storage daily basis, right? Bytes into 90 divided by 10 to power 12. This will give this size into the TB. Then total storage with replication multiplied by 3, and then and petabytes, right? Then we are going to calculate the bandwidth estimation, average text bandwidth. So in order to average text bandwidth calculation, so what it says, text byte per day into 8, because we are going to convert byte into bits. So 1 byte is equal to 8 bits divided by 86,400. So mbps, it will just provide the mbps. Okay. Because after that we're just dividing by 10 to power 6 also. So this bits will get converted into the megabits per second. So text byte per day 49 text byte per day, this much, divided by into 8, and divided by 8600 86,400, and then divided by 10 to power 6 also, in order to get it converted into mbps. Then average media, or average media, we have to go and refer this one. Okay. And everything will be get converted into the mbps, because generally network bandwidth, right, even the internet bandwidth we talk about, so the unit is mbps, kbps kind of thing, right? So 100 mbps internet broadband connection generally talk about at home, right? So in that term only I'm talking about this media bandwidth. Then total average bandwidth, just summing, just I believe we are just summing it up. Yeah, text plus media divided by 1000. Okay. And then, yeah, this same only 22, see, 22.22 comma 828.84 22. When we are going to divide by 1000, so it will give this number only after the rounding up. Then peak, again divide, multiplied by 3, media bandwidth via CDN. Okay, so for that calculation, so we need to, what we are doing, we are just multiplying this value, the total average bandwidth, and the hit for the hit rate, I mean cache hit for the CDN, that is 75%, right? That's what I'm doing, multiplied by 0.75. So that's what this value is telling about. And then origin fetch bandwidth, we talk about this one. So for only 25% of the requests which are going to the WhatsApp, right, rest 75 is handled and managed by the CDN. So for the 25% of the request, we are going to calculate the bandwidth, which is coming as a 5.62 GB. Okay, that is acceptable. I mean, to build a WhatsApp kind of system, that is not a very high-end system, I would say. I mean, system is high-end, but the calculation which we are experiencing here, it is not at very high-end. It is manageable to uh, to set up that kind of infra to uh, deploy this mini WhatsApp kind of application and start serving to 100 million user. Okay, so that is pretty much straightforward. Then when it comes to the database estimation, so here I'm going to talk about the message store. Generally, as part of the architecture diagram, so all the messages, the chat between your friend or between your peers, which is going to store inside the Cassandra. Uh, what it says, 30 days text queue plus 30% index overhead, right? This is database overhead. The val, write ahead log, and the index and the metadata we are talking about, right? And then the 30 days text queue, because generally the text messages will persist on the this WhatsApp server for the next 30 days only. So on the basis of that, we are calculating. So what we are doing, C C53, right? So it's telling you text message queued for the next 30 days, right? Then multiplied by 1.3, this will give that calculation, because we are considering 30% overhead as well. Then user profile DB, uh, then group metadata DB. So there are, in DB we are also this DB is basically we are using some transactional database. So here in our case, I think we are using Postgres. So user related details, we will be saving, storing inside the MySQL. So what storage would be required? So in general, 2 KB storage would be required to store the user related metadata information, and then multiplied by daily active user. That's how. And the see the information which is telling as a part of metadata, phone number, public key, profile, etc, etc. So that information is coming as a 0.166, right? This is the calculation. C27 C27, if you are saying C27, this tells the daily active users multiplied by 2 KB per user, and then we are just dividing by I think 9 zeros, so in GB it will get converted into GB. Yeah. Similarly, for the group metadata DB, we are considering 10% of the user in the groups with zero point 0.5 KB per membership entry. So using that calculation, uh, DAO multiplied by 10% of the user multiplied by 0.5 KB, then divided by 10 to power 9 to get converted to GB. That's how you're calculating the group metadata. Then for the contact as well, then in order to just calculate the total DB footprints, we are just adding each and everything, converting into TB, and with replica uh, for the uh, for the peak situation, right? So because DB, then we are maintaining the replica as well for the high availability fault tolerance system, right? Multi-reason kind of setup in different availability zones. That is pretty much fine. Then coming to the CDN requirement, content delivery network, right? So here we are going to talk about the daily media volume, which is media bytes per day. Okay, it is straightforward. We already calculated as a part of C15 row, C50 row daily media storage, and just dividing by 10 to power 9 to get converted to GB. Then CDN served media, again with considering 75% hit rate. This will be the value. Then origin fetch with 25% miss rate. Then it's just for that CDN. Okay, even for the CDN network, right? So it is a group of the edge devices as servers. So they are also, it's not like that we are keeping everything inside the RAM or everything inside the inside the disk. There is a 10%. This is assumption. 10% of the information we are keeping inside the RAM as well. So that assumption we are taking 10%. Then we are calculating out of this much data, right? 10% we will keeping inside the RAM as well. So this is that, and this is it about the CDN. Now next we're talking about the backup estimation. For the backup estimation, see, it was the 1.5% calculation we are taking, right? So primary data we are considering as per the previous calculation that we have stored in line number 55, this much total storage with replication. Now considering the backup with 1.5 times, this is the value we are getting. Then thus we are just converting into the petabyte, and then the daily incremental backup. So daily growth with the replication factor we are considering. So what we are considering here in terms of the daily incremental growth. So daily growth, which is C52, which tells, see, we already have calculated that thing, right? After adding all those things, right? So daily growth is this thing, okay, with the replication factor. Then this is the future growth estimation for the WhatsApp like a system. So how we can do the 1 year, 3 year, 5 year, and 10 year plan. So this spreads is editable. I mean, whatever the assumption we are taking into consideration as per the latest market study, we will be just updating those information here. And with respect to those information, the underneath calculation with respect to the DAO, message per day, read write peak, storage estimation, bandwidth estimation, database estimation, CDN requirement, backup estimation, future growth, each and everything will be calculated automatically. I hope this capacity planning part is clear to you guys, so that now you have done the capacity planning like YouTube like system. Now you have done WhatsApp like system as well, you're feeling more confident about your skill set, I believe now. So that is pretty much cool, and your yours should be high, I believe, because you're following my channel and you're going through each and every things in detail, in granular level. So your confidence should be at as high as possible. Okay, and this is what I want from my audience. And so in terms of the deliverables, we talked about each and everything. But, okay, just take a look about the architectural diagram. Okay, so take I will just use my epic pen, choose my, okay, it's not yet selected, let me select it. Okay, it's done. So guys, if you talk about, okay, if you talk about this WhatsApp like system for the 100 million user, so at first layer there, which is nothing but a client layer. So this layer, what will happen, like you will be interacting your WhatsApp application from your mobile devices, from your browser, laptop, okay, iPad devices, and any other medium you can use if it's able to run your WhatsApp application, right? So that is pretty much simple to understand. So as a client, you are using those browser or mobile app or uh, iPad, right, or Safari browser, anything. After that, uh, the traffic will come to the global traffic manager. Okay, so because there are 100 million users, there are 100 million user that going to use this WhatsApp like platform. Okay, so traffic will be more, there will be traffic manager, and then it will come to the global load manager, basically. Because because just try to understand in such a manner, you're going to a bank, okay, you as a customer, and there is one cashier. It will take, uh, I mean, that is manageable for him if there is a one customer. What about if there is a queue of 10 customers, right? So it will not be able to uh, feasible for one cashier to serve all the 10 customers, right? So it's better if there are customers coming, customers, okay, let them come. There is a one, uh, there is one manager, okay, I will say, uh, uh, what could be the name I can think of? Suppose a receptionist only, right? There is a one, the one person who is trying to manage this crowd, which is coming as a 10 users sometimes or 100 users. And what is his or her role is, when the traffic is coming, okay, the person is coming and they want to come to meet to cashier for some of their, I mean, transactions. Okay, they want to uh, deposit some money, or they want to withdraw some money, right? So in that sense, it will try to sense the traffic. If there are less customers, if there are more customers, accordingly it will send to the cashiers. So cashier 1, cashier 2, cashier 3. If there are 3 cashiers, that person knows that which cashier is available. Okay, so if cashier with lesser customers to serve, as in when the customer will come, it will try to divert or route to that customer to the that cashier to serve in a better manner. Similarly, you can consider this this receptionist. Recep- receptionist. Just consider this. Just bear with me. Just forgive me for this spelling mistake, guys. But considering this receptionist as a load balancer, this is what your load balancer is doing here. Okay, so whatever the traffic, if the concurrent user, let's say there are 20 to 50 million concurrent users are there, to handle, to serve those many requests, right, for this WhatsApp like a platform, we would require a load balancer which can sense, and accordingly it can route the traffic to the respective services. Okay, suppose primarily we are going to use this chat services, so there we can use the multiple instance of chat services in terms of the scalability. If more traffic is coming, and accordingly each chat service can serve at some, let's say 50k 50k, some in terms of chunks, right, we can equally distribute the whole traffic in some equal chunks, and every customer service instance can serve those equal chunks in parallel. Uh, that's how the things works underneath, right? And that is the importance of the load balancer to manage the huge traffic in general, in practical, in real time. Then there will be the API gateway, guys. There will be the API gateway. So what it does, it is nothing but a entry point for your collection of services or components you are offering to the customer as a part of your WhatsApp application. So there will be the auth service, there will be the chat service, there will be group service, then there will be presence service, then there will be media service, notification service. Okay, so these will be services available at high level as a part of your WhatsApp like application. For the auth service, we are system design wise we are using Postgre, right, because generally the user related information we will be keeping it here, right, and the ACID transaction, the update, insert, update, delete kind of those transactions will be doing. So Postgre or any transactional database is the best fit for that, so we are using Postgre here. For the customer service, this is the main service, this is the heart of, I would say, the whole I mean I would say the this is the heart of the this WhatsApp like a platform or application, because primarily its application is, or its use is sending and receiving the message, right. One of your friend will say, send the message, and at the another end your friend will be receiving the message. So this is the primary service or the flagship service of your WhatsApp like a platform. Additionally, there are many other services, many other components, but this is the utmost priority service, right. So here there will be concurrent or more frequent writes will be happening, because here the actual data will store, right, whatever, suppose you are saying hello to Raj, then Kamal will be receiving that message, replying something, how are you, so those actual data will get stored inside the Cassandra, and Cassandra is best fit for that, storing that kind of data. I mean the heavy writes, scalability, right, fault tolerance, high availability, for that kind of system Cassandra is the best fit. So that's why we are using Cassandra messaging system here. Then for the group, so there will be scenario like you might be the part of, or you will be creating some of the WhatsApp group, adding some of the people inside that and sending the messages, right. Then suppose there is 100 members inside your one of the group, so one message will be like the 100 transactions, right, or 100 API calls for the chat, right. So those kind of activities will be happening as a part of group services. Then again those actual data will be stored inside the Cassandra. Then there will be the present services. It will try to address the current user, uh, current, what I will try to do, suppose in the current session of the user, user is, I mean, it's related to present. So there will be the status like online, offline, typing something, that kind of things you might have noticed, right? So there will be the situation where in the current session there will be continuous uh, updates, right, will be happening on the status of the user. So to cater that kind of requirement where the multiple or in millions per second kind of transactions are happening, so to build that kind of system, basically we would require redis kind of in-memory system, uh, because the response will be less than in 1 millisecond of order. And it is also scalable because redis, as and when it's required, it more noded nodes can be added horizontally, and we can scale the system to cater more users in future as well, right? But primarily it stored the very minimal information at session level, like for every individual, like if that is online, offline, or writing something or typing something kind of thing, right? So I hope you understand the functionality of the presence service. Similarly, for the media service, whatever the media content we are sending, right, inside the group or between one to one chatting, like some images can be sent, some audio, video, that will be stored inside the object storage, and there is no issue of the scalability, right? It can scale to the petabyte of order. So that's why we are using I mean storage, object storage services, be it S3 bucket, ADLS, GCS bucket, right? And we can easily store those media files. Yeah, so we can easily store those media files to create this scalable storage solution to serve this media service. Then there is another service, notification. I mean, suppose your message got delivered, so that delivery message, right, to be sent to the to you, whoever is the sender. So in that kind of those notification is being sent through the Kafka. Here we will be using Kafka service underneath. Okay, so just try to understand the layer as well. If you talk about this layer, so this is the first layer, client layer. We would be saying this is the edge layer. We would be saying generally edge layer. This is all the edge layers basically, and technically we call it. And then this layer 3 is the business service, where all the services we have mentioned. And then this layer 6 is nothing but a data layer, and this layer 7 is the content delivery, so content delivery network, right? So generally this static data got stored inside the this global CDN on the edge servers to provide the 75% hit rate. So for the 75% of the request will be served from the global CDN edge servers for the low latency and the better customer experience, I would say. Then just talk about, let me talk about and the need other things. So here if I'll talk about this thing, so this thing I have covered. Okay, and then the media delivery, then I was saying this Kafka event bus we will be using, right? So that the delivery for the delivery service, for the fan out service, for the analytics service, for the AI services, basically for the delivery service, in the sense whatever the chat service. So if Raj sent something, like hi to Kamal. Okay, so as a part of this delivery service, which is connected to the Kafka event hub, what it will be doing, it will be identifying the recipient after the chat service. After the chat service, hmm, after this chat service, chat service, it will come to the, it will store the data here, then it will come to the Kafka, and then it will identify the recipient basically. Okay, with the help of this delivery service. So recipient is who is the recipient? Kamal is the recipient. Then what it will do? It will deliver the message hi. Deliver the message hi to the Kamal. Okay, that's what the delivery service is doing. Without that, everything needs to be managed by the customer service, and it will become overburden, overhead, extra overhead to the chat. And I mean, that's the whole idea, to create the separate services and connect it through the Kafka event bus. Okay, then there is a fan out service as well. So like whatever the group services, I mean group messages and those media posting is happening. So like if there are 1,000 users are part of that group, right? So one message is equivalent to 1,000 API call to endpoints, right? To chat service, which generally slow down the system. So for that, generally we use the fan out service, which is connected to the Kafka, and what it does, it gets converted into the thousand delivery events delivery events rather than delivery message. Okay, so it will get converted into a delivery event. Now this 1,000 delivery event will be sent to the respective recipients. Okay, recipient. So in case of the situation where it's not able to manage the that much request. So here, since we are connected with the Kafka, we can scale the Kafka cluster by adding more nodes horizontally, right? That is also possible. And Kafka also, in terms of the scaling, it comes with the partition. So partitions again, very scalable, right? uh, Again, there is a concept of the consumer group. So what will happen, suppose there is a one topic with multiple partition, and this partition, suppose there's a multiple consumer group 1 and group 2. Suppose both of them are interested into the this partition, they can parallelly retrieve this information, right? There is no harm that. That's how we can scale the system with the help of partition plus consumer group, right? That is. And for the analytic service, like this is basically connected to the Kafka and the chat service, suppose. So what is doing, whatever the chats happening between Raj and Kamal, let's say, right? So suppose there is a 80 messages has been sent, right? So the metrics, the the analytics, like message sent, message delivered, right, or not delivered, this kind of analysis, right, analytics is happening inside this service, analytics service, basically, right? That's how we got to know. I mean, today these many interactions happen, this many messages got sent, or this many chats are delivered or not delivered, things like that, right? And then there are AI services. So see, for the AI services, basically, it's it could cater with the. This is again the futuristic scope. Again, the agentic approach we can apply here for the auto reply, for any with respect to any chat event, or yeah, with respect to any chat, right? Suppose we just want to create a bot for Kamal, right? So for Raj, let's say, and if Kamal is sending hi to Raj, right? So then we can configure it in such a manner that whatever the request coming from Kamal, it should easily auto reply. And then the translation could be one of the use case. Then the summarization could be the one of the use case as a part of AI services, right? And many more things like knowledge base and all those things. we can add it as a part of our system also, depending upon the whatever the chat history is happening between Raj and Kapil, and accordingly I mean, some question can be asked by Raj, and those responses can be generated. But for this whole setup, there will be different compute would require, right? The different set of GPU based platform, GPU infra would be required for that. Okay, so that is the whole idea. So I hope you are able to understand the whole architecture, which is pretty much clear and easy to understand. Let's talk about the scaling aspect, which is also pretty much important, right? So I will just touch base few of the things. Uh, just select blue. So for this, no, blue is not good. This is already dark background. So for client layer scaling, if we talk about, right, which we are saying that any mobile device browser could be the that layer, or the global traffic manager or load balancer. So at that layer, if we talk about, because there are different layers in which guys, let me connect the dot. So here I'm just talking in terms of the layer, okay, whatever the calculation I'm doing. So layer one. So when I'm saying layer one, so this all things is coming, right? Okay, okay. So similarly for the layer three, what I'm doing for this business service layer, for the data layer, what kind of scaling we can do at layer seven. For the content delivery networking, what could be the scaling for the event streaming, what could be the scalability perspective that actually I'm discussing. Hope you're able to connect those dots. Yeah. So guys, for client layer scaling, so this is the whole setup basically, right? From from any browser mobile application, those requests are made, right? Then it's coming to the global traffic manager, then the load balancer, then it's saying the geo routing concept, geo route. So what it says, route user to the nearest region, right? So there could be the one of the provision, like all the India users going to the, I mean, going to serve from the APAC region instance of WhatsApp. Similarly, all the US region customers who were making those requests, right, in terms of the, I mean, sending and receiving the message, right? Basically, this is the primary activity that will be doing the WhatsApp. So for all the US users will be served from the US region. Similarly, for the European users will be served from the European region, right? So in that manner, there will be low latency and the reduce cross region traffic and better user experience overall. So the overall thought is we can use the global load balancer, right? That's what I was talking. So let's break it down to understand. So the idea is global load balancer. So we will be using load balancer at the region level. So the requests which are coming from the user chat request, right? So if the load balancer is there and the request is coming from the, so just I'm creating region wise, I'm just this. So this application, suppose this application instance, this WhatsApp instance is deployed on the US region, Asia region, then European region, right? So in that case, it will identify the request is coming from the user request is coming from India. Then it will try to route this request to the this Asia region, where this WhatsApp instance is up and running, so that it can quickly respond back and the latency will be low and the user experience will be good, right? That's the whole idea. Then the API gateway is the point from where the main functionality of the application start. If it is the chat service, right, it's a notification service or the media service, anything, right? So what it's saying, this is the API gateway. So this is one of the most critical layer, right? So what if WhatsApp primarily use persistent connections for, let's say, 100 million user, 6 million the concurrent users, as per the capacity planning that we have done it, right? So the idea is, for the horizontal scaling, if the traffic is more, right, if the traffic is more coming from here, because there could be the 6 million concurrent user we using that WhatsApp application, in that scenario might be one gateway is not able to serve, right? So from the one node, so multiple nodes can be added to here as well to scale horizontally to serve 6 million or more concurrent requests, right? So that's the whole idea: gateway node 1, 2, 3, and so on. So each node can handle, let's say, 100k to 500k connection. So suppose this node can handle 100k request, this can handle 100k request, and this node can handle 100k request, right? So that's how we can just balance this load, the request, concurrent requests coming from the this global users, right? So this is one of the scalability aspects that we can consider when our client is saying, the system you have created, it can serve 100 million. What if I want to serve 500 million or 1 billion users, right? In that sense, you need to think at each layer level, that okay, what I have can do at the load LB layer, what what all things we can do at the API gateway uh, level, right? So we can horizontally scale that system by addition of more nodes. Okay, I think this is pretty much clear. Then let's go to the, yeah, similarly, see the chat service level as well. This is the most heavily used service, right? From the load balance, it comes to the API gateway, then it comes to the chat service. This is the one of the service offered by the WhatsApp, right? So what we are doing here in the chat service, see user load balancer. So see, if there is a one chat service instance, right, so it cannot able to serve all the requests coming from the I mean 2 million, 6 million, 10 million, 100 million users, right? There, because there will be some capacity of the resources as well. So you will end up seeing the error like 100% CPU utilization, right? 100% RAM utilization. So the system will get hanged in that scenario, right? So in order to serve in a better manner, we can again scale horizontally, um, add more instances, right, of that. That is the whole idea. More instances of shared services. This is nothing but the replica of the this chat service only. So this is the first replica, this is the second replica, this is the second replica, and this is the third replica. Okay, and this is how it can cater the request from the coming from the API gateway. I think this is pretty much clear. Then coming to the Cassandra scaling level. Okay, so there is the database we are using to store the actual messages, right? So at that level, the chat services we are primarily using a flagship application, sorry, a flagship service of WhatsApp, which is a chat service primarily. Just I mean, making sending the request, receiving the request, sending the message, receiving the message from one end to another end, right? So this chat is the main service, and this chat content will be stored inside the Cassandra to which supports the heavy write and the scalability at the same time, right? So that's the whole idea. And why this is being said, because uh, in order to scale it further, we can, it supports the partitioning as well. Partitioning, and partitioning can be done on the conversation ID and or at the user ID level, right? So we can do the partition, we can get the benefit of the partitioning just like the Kafka in order to scale. This is one part. And then additionally there is a, it also support the horizontal scaling. So in case of the uh, many users, like 1 billion user, what customer was asking for, right? Is your system is scalable to the 1 billion user as well? In that scenario there will be more data to store in terms of the chats, right? So we'll be doing the horizontal scaling by adding the more nodes. So that is also feasible add, right? Then again it can also scale at the multi-region level, right? So like adding this node to the US region, Asia region, then European region, and keeping the replica as well into the different region availability zone with the help of availability zone, right? That's how the high availability thing is also achieved with the help of the Cassandra. That is also, I mean, one of the reason being to choose Cassandra to store the actual data. Okay, see this multi-region US Cassandra, European Cassandra, Epic Cassandra replicated asynchronously. Then the Kafka scaling, we know that partition, it can scale using the partition scaling, right? We know it, that thing, right? Scaling partition level, then consumer group level, that I already explained to you guys. So if I go down group service, so there was a group service as well, right? So it is basically to use by the users, where they create the group, right, and add the 1,000+ users, and then start chat, sending the communicating between, sharing the media, all those things, right? And there we are saying group this group service is connected to the Kafka, and that is connecting to the fan out service. Fan out service, right? That's what we we have seen above as a part of WhatsApp architecture. The problem was like group with 1,000 members, one message become 1,000 deliveries. I mean, explained this concept above only. So Kafka based fan out, what it does, the group message, then Kafka is in between, right? Then fan out, what it does, like in terms of the more messages, in order to cater or serve them properly, they can horizontally scale the Kafka as well, right? However, underneath it treated those 1,000 message deliveries equivalent to 1,000 delivery events. That is the gist about that. I mean, how it's handling. This is all with the help of Kafka. Just convert those 1,000 API calls to the just 1,000 delivery events, right? That's that's how it become lightweighted, and scalable at the same time, because this supports the partition, consumer group, and horizontal scalability. Okay, then I will talk about mm, mm, this presence service. Yeah, I mean, this is also, I already iterated that present service there, which contains this type of status: online, offline, last in typing. So it's set, as of now we are using Redis, right? Because it provides low latency, less than 1 millisecond, and even millions of updates within a millisecond of a time span. So that is the good part about Redis, right? That is the uh, I mean, that is the specialty about the Redis. That's why we are using Redis for storing the I mean update. I mean, that's where we are just using Redis to store uh, this is I mean user status, which are changing very rapidly. Okay, in short spam, because in a user session, what will happen? There will be user session, right? Suppose for the 10-minute user session, multiple times, right, it will come online, offline, typing, then again online, then again offline, then typing, or again online. I mean, this keep on changing, keep on updating. I mean, from definitely from not on to off, on to typing, something like that, right? So keeping the track of these frequent updates in very frequently, right, in very short span, because it should happen very quickly, latency should be very low. So for that decision making, we are storing this kind of information in the Redis only, right? And in order to make it more scalable to cater concurrent request, right? Concurrent users like 6 million users per se, as per the use case we are studying. If it increases to 10 million or so, right? In that scenario, also by scaling this Redis cluster, we can serve it in a better manner. Okay, that's the whole idea. Then media service, I told you already, we are storing image, audio, video, all those things. For that, we are storing object storage, right? So that is already scalable by default, by its nature. All the object storage are by nature is petabyte. I mean, they can scale, they are scalable at the petabyte scale. Okay, so which is I mean, very enormous size of data. So you need not to worry, at least at that level, right? And that data size is too much in itself. So you don't need to a bit concerned about this storage layer, which is object storage layer, and we are using like S3 buckets or ADLS or the GCS bucket for your reference, right? So it is already scalable, direct upload, blah blah things. Okay, that's fine. And apart from that, basically CDN scaling, I would say. So for the CDN scaling, let's talk about what can be done at the CDN layer. So generally object storage, right, coming to the CDN. So all the static content we are storing in the CDN, edge servers, edge caching, images, all those things I'm talking about, cached near user, generally whatever the region user belongs to, right? So generally we'll be saving those information, those static information uh, on the edge server of nearest region only. That's the whole idea. The benefit I already told you, like reduce original load. It's not going to hit the basically the origin instance of the application. From the edge server only, it will go and retrieve the information for at least for the 75% of the, as per the market research data for the WhatsApp. reduce the latency, reduce the cost. Then the global edge network, right? Yeah, there is a concept of the global edge network as well. So like you can consider it as a region wise, right? So like CDN, if I'm talking about, so there I'm saying, right, for the Asia region, and for the US region, and for the European region. So there will be cluster of the edge servers, right? So that's what I mean. They are calling it India edge, Singapore edge. Even it is more granular level here. I'm talking about the region level here. Even in Asia, also India, Singapore, right? That thing is also achievable. So that's how we can also scale up, because see, it's already cluster of machines, right? Computers. And then I'm talking about, guys, Postgre scaling again, for any. Okay, let me cover it quickly, guys. So for the Postgres scaling, it's again some transactional database. For that, there is a strategy of read replica. Three replicas we will be creating, through which we can scale it up. Read, scale horizontally. Okay. Then there is a concept of sharding. So if one single, because generally it's vertical scaling, right? So one system become huge and not able to serve the requests quickly. We will just split in the, let's suppose, three equal size chunks, and then some range of the users will be served, like 50k users related, 50k users related activities will be served or handled from this chunk of the database, and next 50,000 chunk of the request will be handled by this chunk of the database, and then similarly the remaining will be handled by this remaining chunk of the database. That's how the sharding works, and that's what we can apply in the case of the I mean this transactional database like Postgre, MySQL. Then the delivery service, we'll talk about this. So what it says, nothing but this is a Kafka type. This is Kafka type, right? So their consumer group partition, all those things already have discussed. Then AI services. There I mentioned the key features: smart reply translation, summarization, spam detection. These kind of services we can expect as a part of AI services. But in terms of scalability, we would require the separate GPU pool to serve it, right? We cannot mix with the infra capacity provided for, or infra capacity just we use to deploy our WhatsApp application. Because if you're using the same capacity on which our WhatsApp application is running, then definitely it will slow down the our main application of WhatsApp, right? So idea is to use the separate GPU pool for that, right? To support the AI loads. So that's the whole idea. Now, yeah, now there is another approach as well. I mean, that I'm just explaining you as a bonus of today's session. That also you can take consider while creating doing end-to-end capacity planning of any system, right? So like WhatsApp kind of system, we are considering so many strategies, right? So many approaches in order to create a robust scalable system. So here, this is also one of the approach through which you can create the scalable system. See, the global traffic manager, right? So like with respect to every region also, we can in every region we can just run the replica of the this API gateway, or chat service, ready service, Cassandra service, so that it can work flawlessly, very efficiently in every other, like US region, or European region, or APAC region, very efficiently. And the idea will be like, if the request is coming from the US region, so the traffic manager is going to route the request to the US region application instance, so that it can quickly get served from the application running on the US region, right? So that's the whole idea. about setting up this multi-region scaling strategy. Okay, so as a, I mean, while I was just preparing the note for it, so I have just documented, prepared the cheat sheet as well for your quick reference, which you can consider for your quick revision. Like global load balancer, right? It can work in a multi-region manner. Then API WebSocket gateway, it is a horizontal scalable. Chat service is stateless auto scaling. Then Cassandra is also node expansion starting. Kafka partitioning, consumer group, Redis is Redis cluster, group messaging, fan out workers, media services like direct object storage upload, because we are using object storage, right? So it is pretty much auto scalable. CDN is like global edge catching, like India, Singapore, US, global edges we are using, right, for the CDN to work efficiently there. Then Postgre, we can use the read replica and sharding concept to scale it in proper manner. Then for the AI services, independent GU cluster, GU infra would be required so that it run independently without impacting the performance of our WhatsApp application. Okay, that's the whole idea. So guys, I have pretty much covered each and everything what I have planned for today's session. Okay, so everything I have covered, be it the deliverables and doing the capacity planning, which was the main agenda for the today's recording, and the assumption calculation I have shown you bit by bit, line by line, end to end, then the final architecture, then the scaling strategies, right? So this is what I have explained you in detail. I hope you are liking this video. Okay, and you are feeling confident now to build any kind of similar architecture, right, for your client or for your personal project. With that, I'm signing off, and I hope you have learned something. And remember guys, keep learning, keep growing, and keep building together. Thank you.